All right, it is January 17th. Oh, that's funny that I wrote that up. 2020. All right. This is the last section. We are going to spend a few days on this section. Then you'll have a review day, and you guys have a test on 4.1 to 4.4 on Friday, a week from today. That's the 24th, I believe. So good to know. Your unit circle project posters are due on the Thursday, okay, which gives you the weekend and Tuesday and Wednesday to get that done. And so they're due on Thursday, and then your test will be on Friday. Thursday will be a review day in class, and then test on Friday. It is the first test, and so it's kind of important because that'll pretty much determine your grade for the progress. All right, so you want to do good on it. I'm pretty sure most everybody did pretty good last year. Okay, so real fast here, cosine of 4 pi over 3. Making a little sketch. I'm going to take pi and divide it into 3 pieces on top and 3 pieces on bottom. Make a little sketch of my angle, 4 pi over 3. 1, 2, 3, 4 puts me here. There's 4 pi's over 3 in my third quadrant. And can you envision the little legs of that triangle? We have a short leg and a long leg. So what is this ordered pair? Negative 1/2 and negative radical 3 over 2. Very good. And so the cosine at this angle would be negative 1/2. Okay. The ordered pairs, alphabetical, cosine, sine. All right. 11 pi's over 6 is almost all the way around the circle. And so hopefully you get to the point where you don't really need to do all the dots. You just know in general where it is. Okay. And if that's right here, 11 pi's over 6, then there's a 2 leg lengths there, and it looks like I have the longest leg, so radical 3 over 2, and then I got to go down a tiny bit, so negative 1/2. What is the sine at 11 pi over 6? Damn it. Look at me, getting 1/2 again. Can I pick another number? Okay. I don't know how I do that. It's very weird. All right, 2 pi over 3. 2 pi's over 3 is about right here. And that would be negative 1/2 and up, radical 3 over 2, short leg, long leg. And so how do we get tangent? Y over x or sine over cosine. I'm going to use sine over cosine more often because you need to hear it so that you remember it's sine over cosine. We need that later. So that would be radical 3 over 2 divided by negative 1/2. And what happens to clean that up? The denominators reduce, and we're left with a radical 3 and a negative. So negative radical 3. Okay. So today we're looking at trigonometric functions of any angle, and it's important we understand we might not know what that angle is, and so we really need to be careful with how we're drawing things, and you also need to understand that these aren't angles on the unit circle. All right, so we're going to have to go back and use SOHCAHTOA to figure those things out, and the best way to do it is to draw a picture. So example 1. The point is on the terminal side of an angle in standard position. Determine the 6 trig functions of the angle. Determine the 6 trig functions of the angle in standard position. the first thing I want to do is draw a picture. This is a point, an ordered pair in our XY coordinate field. So what quadrant is -4, -1 in? Third quadrant. So I'm going to draw that. There it is, about right there. -4, -1 is the point. And that is a point on the terminal side of an angle in standard position. So an angle in standard position would be, here's my initial side, and it's opening. And here is my point that falls on the terminal side of an angle. Okay. And so there is my angle. Now, I've mentioned this before briefly, but this is where we have to understand reference angles. We have to turn this big angle, which is large, more than 180 degrees, right? Although they also didn't specify that it could be in the negative direction. I'm assuming it's positive. But even still, they all land on this terminal side here. And so what we're going to do is create a reference angle or a reference triangle. And to do that, we drop an altitude. And when you drop an altitude, it always goes to the x-axis. And when we do that, we create a reference triangle or this reference angle. The reference angle is right here. And that is our angle that we use to reference our trig ratios. So I'm going to erase that little arc mark. So this angle, the angle between the x-axis and my terminal side, is always an angle that is less than 90 degrees and greater than 0. It's always a positive angle, less than 90 degrees. And that is the angle that we use to reference our trig ratios, okay? And so what I've created then is I have some legs of the triangle. What is this horizontal leg length? -4. And what is this vertical leg length? -1. And so you see what's happening here now? This is not a real triangle, is it? Because real triangles will never have negative leg lengths. Okay, so we've moved into theoretical land where things have positive and negative values just based on their position. Okay, so kind of interesting. What we need to do then is figure out the third side of the triangle. How do we figure out that third leg here, third of the long side? Pythagorean theorem, sure. So -4 squared plus -1 squared equals our radius. I'm going to call it r, radius squared. Be careful when you do this. Either do it in your head or be careful with your calculator. Use parentheses. Should always get positive values. So 16 plus 1 is the radius squared, which is 17. And then we square root. And so we get radical 17. Now, the radius is always positive. And it's always positive because it is still a radius of a circle, okay, which is kind of weird, I know, but the hypotenuse is always going to be positive despite the fact that the legs might be in negative values. Once we find the third side, then we can figure out all 6 trig functions. So sine of our, do I know how big this angle is, theta? No, I don't really know. It's very large. Larger than 180 degrees because it went from all the way around here to here. But we still get to use this little reference triangle we created to help us figure that out. So sine theta, cosine of theta, tangent of theta, cosecant theta, secant theta, and cotangent theta. So sine is opposite over hypotenuse. So again, we're referencing this little teeny tiny angle here. What is the opposite of that angle closest to the origin? Yeah, -1 over radical 17. And if you rationalize, what do you get? Negative radical 17 over 17. Very good. Cosine is adjacent over hypotenuse. And again, we're referencing this angle closest to the origin. So the adjacent side would be negative 4 over our radical 17, which would rationalize to be negative 4 radical 17 over 17. And what's tangent? Oh, it is sine over cosine. That's true. But if I have a picture, can I just do opposite over adjacent? Yes. So opposite over adjacent would be negative 1 over negative 4, which is a lot easier to work with than all this garbage, despite the fact that most of it would cancel. So positive 1/4. So sine was a negative value, cosine was a negative value, but tangent was a positive value. That's something to pay attention to. All right, what would cosecant be? Negative. I'm going to flip this one because that would be easier. So you can see if you flip that, it's just going to be negative radical 17 over 1. What's secant of theta? Negative radical 17 over 4. Again, I'm flipping the one before we rationalized. And then cotangent is going to be 4. Okay, questions on that? So they give you a point on a terminal side. You got to draw a good picture, figure out your reference angle, which is the angle between the terminal side and the x-axis. All right. We've done a little bit of this already, so it should be nothing new. They just have weird directions. Evaluate the trig function of the quadrant angle. That's one way to say it. I read it, quadrantal angle. What this means is these angles, which are angles that look familiar to our unit circle, these angles fall on an x or y axis. So again, I'm just going to draw a picture. Evaluate the trig functions of the quadrant angle. Cotangent of 3 pi over 2. 3 pi over 2 is an angle in my circle. So thinking that through, I'm going to go to pi. And what do I have to cut pi into? 2 pieces, 2 parts. So I'm going to do that on top and on bottom. And then to draw this angle in standard position would be 1 pi over 2, 2 pi over 2, 3 pi over 2. So it comes straight down. There it is, 3 pi over 2. And so if we're thinking about our unit circle, what point is that on our unit circle straight down? 0, negative 1. Very good. And we know this is cosine sine. How do we figure out cotangent? Cosine over sine. Very good. Cosine over sine as opposed to tangent, which is sine over cosine. So cosine over sine, the cosine value is 0, the sine value is negative 1, and 0 divided by any number is 0. All right, cosecant of 2 pi. Again, 2 pi is a number on our little unit circle. And so this is an angle that has an initial side at 0, and then it travels all the way 1 pi around and 2 pi and lands right back where it started. What ordered pair does that land at? See? Careful. Watch those zeros and ones. 1, 0. Very good. Very good. Okay. Cosine, sine. Oh, sine. I keep writing secants all the time. Okay. How do we figure out cosecant? Reciprocal of sine. The reciprocal of sine Well, right now sine is 0 over 1. And if I flip that, it becomes 1 over 0, which is undefined. When the 0 is under, it's undefined. You can bet money that I'll put something like that on the test. Okay. It's important we understand when you're undefined, that creates an asymptote graphically. Okay. And so we'll be graphing next after the test. Okay. I love graphing. It's super fun. All right, last one. I think. Oh, yeah. Okay. Example 3. Evaluate the sine, cosine, and tangent of the angle without a calculator. Without a calculator, because these are friendly. Granted, that doesn't mean you couldn't use your calculator on a test to check. Evaluate sine, cosine, and tangent of the angle without a calculator. See people thinking that through in their head. It's so cute. All right. So I'm going to draw my angle. Here, my angle is 150 degrees in the negative direction. And again, it's always an angle in standard position. So my initial side is on the x-axis. Where would 150 degrees in the negative direction fall? Third quadrant, yeah. So in the negative direction, 150 degrees lands about right here, pretty close to negative 180 degrees. All right, pretty close to that straight angle. That is a lovely friendly angle, so we can say what is the sine of negative 150 degrees and the cosine and the tangent. Because we know this is a point on our unit circle. It's a nice friendly angle. What is that ordered pair? Negative radical 3 over 2 and negative 1/2. Very good. Long leg, short leg. So sine of that angle is going to be what? Negative 1/2. Very good. Cosine, sine. Cosine will be negative radical 3 over 2. And tangent, how do we find tangent? Tangent is opposite over adjacent, but I don't have those legs labeled. Sine over cosine works better here. So sine is negative 1/2 and cosine is negative radical 3 over 2. What happens to the denominators? They cancel. And then we have negative 1 over negative radical 3, which is what? Radical 3 over 3, and it's positive. Very good. 2 pi over 3. Again, little picture. So I'm taking pi and putting it into 3 wedges on top and bottom, but I'm just going to draw the top because that's all I really need. I should have done it over 4. Okay. All right, so there is 2 pi's over 3. What is that ordered pair at 2 pi's over 3? Negative 1/2 and positive radical 3 over 2. So we can do the sine of 2 pi over 3, the cosine of 2 pi over 3, and the tangent of 2 pi over 3. So again, sine is radical 3 over 2. Cosine is negative 1/2. And what's tangent going to be? Sine over cosine, so that's radical 3 over 2 divided by the negative 1/2. So again, the 2's cancel, and we get negative radical 3. I was listening to Journey on the ride over, so. Okay, do you have any questions for me? Oh, your booklet. Oh, nice. All right. There you go. Have at it.